Hi there. I hope you enjoyed the video. She's quite engaging, Jo Boaler. So I want you to think right now and jot a couple words down. What resonated with you from her talk? Awesome. Okay, we're going to jump into our number sense and reasoning routine right now. Today, we are going to be exploring visual patterns. And there is a wonderful website by Fay Nguyen who created lots and lots of visual patterns. And as Dr. Boaler explained, one of the things that we can do when we see these patterns before we even look at them numerically is really take time to notice and wonder. And you'll see as lots and lots of new number sense and reasoning routines come out into the educational world, many of them start with this idea of noticing, taking stock, and wondering, thinking critically. So today, what I'd like you to do is I'd like you to look at this pattern. And I do apologize, up in the right-hand corner, it's 2 red cubes, followed by 3 red cubes, then 3 more, then 3 more. So how do you see this pattern growing? Would you please jot a couple notes down in your notebook? Awesome. So maybe you notice that each time the pattern grows, there's another row of 3 that's added. Maybe you were looking at these 2 cubes here and thought, wow, each time the 2 stays the same. There are lots of ways to see this. You might also have focused on the color. There was a blue one, then a green one, then a yellow one, then a red one. And all of these are important ideas because our students might say the same. So now let's have another look. And I want you to think about how many cubes might be in the next step, which would be the 5th step. What might you do? Are you drawing it out? Do you already have some sort of a procedure that would get you to that 5th step? You might want to think about a procedure now. How many cubes will there be in the 10th step? This is pretty tricky. Typically, one can write a procedure or an equation or expression that can be followed for the second expression in the pattern. The one that's tricky is making it work for the first one. So take some time to see if you can create an expression that would work for any iteration of this pattern. First iteration, the second iteration, the 3rd, the 4th, the 5th, the 6th. So I wonder what you came up with. Did you think about the 2? And did you think about the 3? And when you thought about the relationship between the 2 and the 3, did you think about what was missing from the 2? What could we add to that 2 to make it 3? So if you think about this pattern as each iteration being the number of the iteration, meaning 1, 2, 3, 4, 5, 6, etc., times 3 minus 1, would that work as a possible expression to solve for any iteration in this pattern? Let's give it a try. 1 times 3 minus 1 is 2. That works for the blue blocks. Let's check for the green. 2 times 3 is 6, minus 1 is 5. That works for the green blocks. So now, maybe you had a different expression that worked. Let's test it out. Let's try and figure out how many cubes there would be in the 10th step. What did you think? Now, let's test it even further. How many cubes will there be in the 43rd step? Nice thinking. This is pretty tricky. You can see that because we are iterating this pattern so many times, by the time you do it 43 times, you're going to be drawing a lot of cubes. So there is a lot of motivation to create a procedure that helps make it more efficient. And when we do that, we do it with conceptual understanding because the students have already created visual contexts of the pattern. They have created noticings and wonderings, and now they're ready to start talking about how can we represent this growing pattern numerically. If we were in the classroom, I'd ask you to explain your thinking. But since we're not, why don't you go ahead and write it down and practice being metacognitive on a piece of paper. Have fun.